The two questions that I have taken from trigonometric ratios, you can figure out that they have the same LHS, but we have different RHS. So let's figure out how to prove this. Now we will begin with, as we have the same LHS, so we can start with any of them. So I'll start with this. So what I can see that over here, we'll be first converting this tan, cot, right, in terms of sine and cos. So first we have tan, and what is tan theta? Tan is sine over cos. So this is sine theta over cos theta, and that whole divided by what we have 1 minus cot, and 1 is 1, and cot is what? Cos theta over sine theta. You have a plus sign in between. Next it is cot. Cot is what? Cos over sine. So this is cos theta over sine theta. That whole divided by 1 minus tan, and tan is what? Sine theta over cos theta. Now what we can do here is to take LCM first in the denominator. So this will result to give you numerator will be sine over cos only. If I take LCM over here, the LCM is what? Sine, right? So the LCM for this, if I take LCM, I'll get sine theta minus cos theta, that whole divided by sine theta. This is cos over sine. This is cos over sine. And that whole divided by, if I take LCM over here, this will give you what? Cos theta minus sine theta over cos theta. Now what next? We will be reciprocating this, right, in order to simplify. So let's say if I do it on the other side. The numerator over here is sine theta over cos theta. And as I said, dividing by this is same as multiplying with the reciprocal. So sine will come in the numerator, and below it is sine theta minus cos theta. Now we have a plus sign over here, right? In between we have a plus sign, and this is what? Cos. And if I divide it, cos over sine, right? It is cos theta over sine theta. And as I divide it by this, it will reciprocate. So this is cos in the numerator, and below it is what? Cos theta minus sine theta. Cos theta minus sine. Now what you can observe over here that we have sine minus cos over here. We have sine minus cos over here, and this is cos minus sine, right? So we cannot take common, but in case if I reverse, take a minus commons from here, we can take common. So let's figure out what we'll get. So the numerator will result to give you sine square theta. Below this is cos theta, that multiplied by sine minus cos. So this is sine theta minus cos theta. So this is sine theta minus cos theta. And as I said, I'm taking minus common from here. So it will be, this sign will be influenced. It will be now minus instead of plus. In the numerator, we have cos into cos, that is cos square theta. And below it is sine theta. And as I said, I have taken minus common from here. So the sign will become positive and cos becomes negative. So now it becomes sine minus cos. Now the advantage over here is now we can take this thing as common. So we are going to get 1 minus sine theta minus cos theta as common. So if I take common, what we'll get inside, this is sine square theta over cos theta. We have a minus sign in between, and this is cos square theta over sine theta. So what we can do over here, we can take LCM, right? So let's say if I take LCM over here, outside we will have this thing only, that is 1 over sine theta minus cos theta. So what is below we are going to do is to take LCM. And the LCM will be what? Sine into cos. Sine theta into cos theta. So this multiplied by sine is sine cube, and cos square multiplied by cos is cos cube theta. Continuing with the simplification, this is 1 over sine theta minus cos theta. And now I'm going to apply a cube minus b cube identity. So a cube minus b cube identity will be applicable over here. Let's say sine cube minus cos cube. I'm going to apply identity of a cube minus b cube. So what is a cube minus b cube? It is a minus b. So this is a minus b bracket. Then we have a square plus b square. So that results to give you sine square plus cos square, right? So this is sine square plus cos square and then plus AB, that is plus sine theta dot cos theta, bracket closed. Below we have sine into cos. This is sine theta dot cos theta is what the denominator. No change in the denominator, just the identity over. So what you can see from now, this is also sine minus cos, right? This is sine minus cos and this is also sine minus cos. So we can cancel them. So let's say if I cancel this, what we are going to get over here is, and what about this sine square plus cos square? But we know that sine square plus cos square is 1, right? So we can replace this with 1. So we have 1 over here plus sine theta dot cos theta, and that whole divided by sine theta into cos theta. Now, what in case if I split this? I can write this as what? 1 divided by sine theta dot cos theta plus splitting, you understand, I suppose, dividing individually. This is sine theta into cos theta. Now, what you can see over here that this get cancelled will be giving you 1. And what about this? I can write this as 1 over sine. And what is 1 over sine? 1 over sine is cosec. And what is 1 over cos? 1 over cos is sec. So after simplifying, we get this. Now let me show you what was our to prove. So if I show you the to prove part over here, below I'm bringing the to prove part. So if I write over here, yeah. So you can see that we got this. We got the answer for the second part, but we haven't got this as the RHS. So what we can do in that case, we will be simplifying RHS to convert them into sine cos. That results to give you this. Well, we have done the second part. Second part is correct. That's a textbook question. The only difference between these two is their RHS is in terms of tan cot. So I'll be taking the RHS. First I'm writing RHS. The RHS over here is 1 plus tan theta. Now since we got this part, I'm erasing it. Tan theta plus cot theta. So 1 plus tan is what? Sine theta over cos theta. And cot is what? Cos theta over sine theta. So if I take LCM, this is going to be sine into cos. Sine theta dot cos theta is the LCM. This will give you, this is sine into cos, 1 multiplied. Plus sine multiplied by sine is sine square theta. Plus cos multiplied by cos is cos square theta. Right. So now keep in mind that this is our LHS. This is our LHS. Now what you can figure out, same way, we can write this sine square plus cos square as what? I can write this as 1. And then if I write them by splitting them, that means we have sine theta dot cos theta plus 1, and that whole divided by sine theta dot cos theta. Now if I divide them by splitting, that is sine theta dot cos theta, this is what sine theta dot cos theta divided by sine theta dot cos theta, and then with 1 over sine dot cos. This get cancelled, which is 1, and this is 1 over sine, as we did earlier, is what cosec, and 1 over cos is secant. So you see, this is our RHS. So check here. On simplifying the LHS, we got this. We got this. On simplifying the RHS, what we got is this. So you can see that, therefore LHS is equal to RHS. And for the first part, as I told you, that we have already proved in between. Till here was the proving of the first part.